Hello everyone. In this lesson you will understand when a function is integrable on some segment. So before that I need to remind you my previous video. In that video I spoke about integrable sum. So yeah, let me remind you. Integrable sum by definition we denote it like this, and it was the sum of all of squares of rectangles under our function. So we denoted it like that, not like this. We denoted, sorry guys, my laptop a little bit lagging, so it's f of ei multiplied by delta x1 plus f of e second multiplied by delta x2 and so on until f of sorry guys, my laptop is a little bit lagging. fen delta xn. So we also can write it like like this, like the sum from e equals to 1 until n f of y of ei multiplied by delta xi. If you don't understand, then check out my previous video. By this is basically means the square of one of rectangulars under our curve or function. It's not have to be curve. So yeah, and in this lesson, as I said, let's start from the definition. Let's start from the definition. A function f of x is called integrable on segment AB. On segment AB if there exists a finite limit limit I, we denote it like I, for the integral sum. For the integral sum. So such limit I, which equals to limit as lambda tends to 0. I forgot this one. Yeah, our sum, integral sum. So it equals, we can write it in this form. So it is the sum of from I is equal to 1 until n f of this multiplied by delta xi. You might ask me, what is lambda? What is this? So let me complete my explanation. Well, lambda is a mesh. We call it mesh. It's mesh of the partition tau. Tau is a set of all elements x naught, x1, x2, x3 until xn, which x naught is less than x1 and x1 less than x2, and they are all in our segment from A to B. Where lambda is a mesh of the partition tau, that is lambda is equal to maximum value of delta xi. Where I from 1 to n. And also, this limit does not depend on the choice of partition tau and points ei, like this letter. No, I won't write it. Okay, so it is from one hand side. From the other hand side, a function of x is integrable on some segment if there exists definite integral. So let me write it there. If the finite limit exists, the finite limit I exists, then it's called the definite integral, of f of x over the segment A from B, segment AB, and denoted like I, which equals to integral from A to B f of x dx. I think you're familiar with this sign. So basically, to sum up all I wrote there, I can say that our function f of x is integrable on some segment if they exist such limit or there exists such integral. If we can find this integral, then it's also this function is also integrable on some segment. By the way, let me a little bit more explain this limit. So it's like the most bigger delta x in the most bigger interval which tends to 0. So we just do more and more rectangulars. The amount of them are going higher, and by this we can write that the most big from these intervals is tends to 0. So then we can define it, and so yeah, we define integral sum of very big amount of rectangulars. So, and from the other hand side, we can just forgot about this limit and say that if we can define this definite integral, then also our function will be integrable on this segment. Thank you for watching.